everyone, this is Asha from the Department of Mechanical Engineering, Global Academy of Technology. In this session, I will be discussing on Routh-Hurwitz criterion, and it is also known as RH criterion. Routh-Hurwitz criterion is an algebraic method of determining the stability of the linear time invariant system. This RH criterion provides information about the system is stable or not depending on the position of the roots of the characteristic equation, whether they are going to lie in the left half of the S-plane or right half of the S-plane. So, the characteristic equation of the system can be written as a naught into s to the power of n plus a1 into s to the power of n minus 1 till an, that will be equal to 0. Here a naught, a1, a2 till an are called the coefficients, and these are typically positive real numbers. So arranging these coefficients of the characteristic equation in the form of an array is known as Routh's array. So Routh's array, you have the characteristic equation. So this is the characteristic equation. So arranging all the coefficients of the characteristic equation in two rows. So starting from a naught, that is the even power. So next will be a2, a4, a6, etc. So the next second row starts from a1. So next power will be even odd power will be a3, a5, a7, etc. Third row, we need to calculate B1, B2, B3. So there is a formula you have to follow. So if you want to calculate B1, it is A1 into A2, then A3 into A0 divided by A1. You will get B1 value. Similarly, for B2, it is A1 into A4 minus A5 into A0 divided by A1. So you want to calculate for C1, it is B1 into A3 minus B2 into A1 divided by B1. So respective formulas for C1, C2, C3 is given here. The same way you have to follow and construct the Routh array. So this is one of the example where the characteristic equation is given. So the first power is s to the power of 6. So it is a even power. So write the coefficients of all the even power. So s to the power of 6, next s to the power of 4, s to the power of 2 and a6. So the coefficients are a0, a2, a4 and a6. Next will be the even power. It is starting from s to the power of 5, s to the power of 3, s to the power of 1. There is no coefficient, so it is considered as 0. So coefficient of s to the power of 5 is a1, next is a3, a5 and 0. So you want to calculate B1, it is A1 into A2 minus A3 into A0 by A1. Similarly, calculate for rest of the array values. So we'll solve one of the problem. Okay, so the characteristic equation is given as S3 plus 9s square plus 26s plus 24 is equal to 0. Okay, so the highest power is S cube. Next is S square, S to the power of 1 and S to the power of 0. So starting from this, the coefficient is 1, next is 26. So second row, it is the even power 9 and 24. So you want to calculate B1, B2, C1 and C2. For B1 it is 9 into 26 minus 24 into 1 divided by 9. We will get it as 70 by 3. B2, there is no third column, so it is 0. So write down the third row, it is 70 by 3 and 0. C1, so 70 by 3 into 24 minus 9 into 0 divided by 70 by 3. That will be equal to 24. So C2, there is no third column, so it will be equal to 0. Write down the values. Since there are no sign changes in the first column of the Routh array and all are positive values. We have 1, 9, 70 by 3, 24, all are positive values and there is no sign change. Hence the system is stable. Hence the system is stable. So for the condition of the system to be stable, the first column values should be positive and there should not be any sign change. Then the system is considered as the stable one. So this is how